Hello all. Um, yeah. Today we are going to discuss about the lead code problem, which is of 169, known as majority element. So yeah. So what is this question? Given an array of nums of size n, okay, we will be having an array of named as nums and of its size of n. We should return the majority element. Now, what is majority element? Majority element is that which appears more than n by two times. So, and you may assume that majority element always exists in the array. So, what is this? Input, we will be having an input of 3 to 3. We should return the majority element, which is 3 in this case. So what is majority element? The element which is present in the array should be appear, which means we should be repeating more than n by 2 times. Okay, yeah, here 2 is repeating one time. What is n? Okay, nums size of the array, what is size? 3. Okay, yeah, see, calculate it. Now 3 by 2, 1.5. It should be more than 1. Okay, now 2 is repeating 1 times and 3 is repeating 2 times. It is more than 1 times. Okay, so 3 is the output, and in this output we are having 1, 2, 3, 4, 5, 6, 7. What is 7 by 2? 7 by 2, 3.5. So the element should be repeating more than three times. Here 1 is repeating exactly 3 times, and 2 is repeating more than 3 times. 1, 2, 3, 4. So here's the catch. Okay, in every element there will be majority element. Okay, see, you may assume that the majority element always exists in the array, so it's no need of checking whether the element is repeating n by no, I mean, see, if we have to check n by 2, then it's an another task. Okay, instead of doing all those things, we can directly use there's an algorithm called Moore's algorithm. Okay, and we can skip that 10 by 2 times. See, yeah. So what is the problem code, lead code number? It's a 169 problem number, and in this majority element is sample inputs like this. For this sample input the output is 2, and for this sample input the output is 3, right? Yeah. Here we can use an algorithm called Boyer-Moore algorithm. What happens in this algorithm? So basically this is like an voting system. We'll be having a candidate and number of votes that candidate have. Okay. Um, let's take this input. Okay, we have to add it first we in this algorithm, first thing we have to do is select the candidate, and the next step is verify what is votes. Okay, sorry, it's his votes. Now selecting the candidate, the first step is selecting the candidate. In this nums array, let's select the first candidate as 2. Okay, so what we have to do, if we get a candidate name for 2s, okay, here the candidate will be first element, which is 2, and when we get the candidate we have to increase his votes more like points. Okay, points, yeah. We have to make his points as 1 because we have selected the candidate. The next we will be coming to second candidate. Okay, second candidate is also 2. What happens now, the candidate is actually 2, and once again it is appearing instead of changing the candidate, since the candidate is same, increases points to 2. Now once again we come to third element, which is also 2, the same candidate, so increase the point to 3. Now coming to the 1, now the candidate is changing, but we should not change the candidate here because we already have 3 points for him. So if we got to candidate as 1, instead of changing the candidate, we'll be reducing his votes to 2, minus 1. And again we'll coming to the another element, which is also 1. The candidate is 2, but we have another candidate one. So instead of changing the candidate, we just minus another one. Now again we'll get one here. Again we'll get one here. We'll change the points to 0. Okay, and we'll put the candidate as 1 because we have 0 points. Since the points is 0, the candidate should be changed. Okay, now we coming to 2. Since the points is 0, the candidate is changed to 2. And last element, since the last element which is also 2, the point is increased to 2. Now whichever candidate is remaining will be the answer, will be the winner of this thing, anything. Yeah, output will be 2. So now let's take this as an input. Okay, let's take this as an input. What we have here, first let's initialize candidate to 0 and his points also to 0. So what should we do first? First we should take the first element. We should select the candidate. Here the first candidate is 3, so let's keep it as 3. And let's make the candidate as 3. We have selected. Since we have selected, let's give his points as 1. Now the second candidate, what is second candidate? Second candidate is 2. Now the candidate is different and we have points as 1. Let's make this as 0. Since the points is 0, let's change the candidate also to 2. Now let's select the other candidate, the next candidate, which is 3. Since the points is 0, let's make this candidate as 3 and the points as 1. Now which is remaining? The candidate is 3 is remaining, which means the winner is also the 3. The 3. Yeah, this is how Boyer-More algorithm works. So here's the code for that. Morris algorithm. Yeah. So let's paste this into the LeetCode. Yeah. Mm, I already solved this. Let's, yeah. Here first we're initializing what we are doing. Like first we're initializing candidate to 0 and then point to 0, and then we are using loop for iterating in the nums. First we'll check the point. If the point is 0, then we'll add the candidate. Okay, we just put the new candidate, and then if the candidate is equals to the element, if the candidate is equals to the element present element, the next element or whatever, whichever element we get in the array, then if it is equal to the candidate, then we just increase the point with 1. If it is not, then we'll decrease the point. So when it comes to the second element, if the point is 0, then it will add. If it's not 0, then if it will check if the candidate is equal to the new element. If not, then it will decrement to 0. Then the next point, the next time, the next candidate will be added, and this goes on. And at last, whichever the candidate is remaining will be returned. So let's run this. Yeah, two sample cases is passed. Let's submit it. Yeah, within 2 milliseconds. Thank you.